Okay, let's go ahead and get started. Good morning, everyone. Beautiful day out there. So today we're going to be talking about map design. You know, this falls more in the field of cartography than the field of GIS, I would say. But as our mapping technologies change, we really need to make sure we keep track of these design principles. We know the most effective way to make maps. And just to introduce this topic, I'll play this short video from John Nelson, who's the chief cartographer at Esri. Lots of great YouTube videos he publishes. But yeah, let's talk about some of the ways we can use cartographic strategies, design strategies to make stunning maps. There are others. Yeah, there's QGIS is the major open source one. Some people just make maps directly with programming languages. There's APIs for ArcGIS, and then there's also just libraries that are free and open source with languages like Python. But ArcGIS and QGIS are the main two. QGIS happens to be free, but it's a little bit less streamlined than ArcGIS. Yes. So I appreciate that question earlier about different software that's available for ArcGIS. in this class, I get you twice a week and you get lab once a week. So it's kind of hard to run the full spectrum of GIS platforms. ArcGIS is the undisputed leader. It's kind of like if you've ever done graphic design and you've used Adobe Illustrator, right? There are free and open source solutions that try to do the same thing. They are free, which is great, but maybe they don't do it to the same level. Another example is if you want to publish your maps from desktop to online with ArcGIS, it's all built in, right? You have access to a server deployment that's already existing for you. That can be hosted on a server so that people can access it. You can turn in your assignments to us with just a hyperlink. You can do the same sort of thing with QGIS, but you'd also have to be a full stack developer, and that you'd need to secure your own server space, or someone at IT at Montana State would have to set it up, and you'd have to make your own server deployments, etc. So, to avoid going under the hood, we stick with Esri in this class. But also a lot of these concepts are exportable to whatever platform you're using. Another big one I forgot to mention is Mapbox. Mapbox is more designed for building applications. So what you do is you design your maps and then you can build applications around that. It doesn't have a lot of the geoprocessing tools that you would find with Esri, things that allow you to actually manipulate your data. So, just some thoughts on that front. Any other questions? All right. So we're going to talk about map design and composition today. This is a super broad field. A lot of it is somewhat subjective, but my goal is to try to give you some tips and tricks that you can implement in your map making to make your maps more effective. So this category really involves all major decision making related to creating maps. So it involves things like choosing your projection, which we talked about last time, symbology choices, typography, use of text, color, and so on. We are trying to make maps that are effective and accurately communicate the intended message. So you can break it down into categories. We have things like the map principles, which include what area do I want to show on my map? What's the scale? What map projection, right? One example is last time we talked about if we're using area as one of our things we're mapping, like a metric of population density, which has area in the actual equation for that, we would want to probably choose a projection that preserves area. We want to optimize our map readability. Here's a few things that you can use to do that: clarity, classification, symbology, legend items, only including those that are actually necessary. Obeying the principles of hierarchy and trying to achieve planar balance, proper focus of attention on your map by the way you lay things out, organizing features on the map, maximizing contrast, etc. So I'll give you a few pointers on how we actually achieve this in the cartographic workflow. And we're really focused on this middle part here, right? We're not manipulating data here. We're choosing how to symbolize it to actually communicate what we intend to communicate with our maps. So here's an example from quite a long time ago at this point, but if you make a mistake in this process, if you forget one of the aspects of the map design process, it can have a poor outcome. Here the color scheme was obviously not tested for the conversion to grayscale. So when the map was printed, it was probably red and blue states, right? But they all came out as the same color on grayscale. And this was actually published in the Wall Street Journal in the print edition back in 2012. So we want to avoid these types of pitfalls. So for this discussion, I do want to remind you of what the difference is between a reference map and a thematic map, right? A thematic map is going to have a stronger visual hierarchy. And you're going to try to achieve that by using more contrast between the thematic layers, in this case, the Texas hydrocarbon pipelines, and the reference layers, which kind of fade into the background. One of the key features of a general purpose map is that no one layer is assuming more importance than the others, right? So for this same map of Texas, same geographic extent, we've achieved a reference map design here by not giving the pipelines a bright yellow color, by not desaturating the background, right? We haven't made it into a simple grayscale color scheme. We still have greens there showing forested areas, etc. So your symbolization strategy will definitely depend on what type of map you are making and what is the intended message you wish to convey. And the simplest way of kind of separating two major classes is thinking about these as reference or thematic maps. All right, so take a second and look at these two examples, right? These have differences in their visual weight. So who can tell me about that left side of the screen? You know, where is your attention first drawn when you are actually looking at that map? To the key, to the legend. Yep, so down in the bottom left, we have huge text, really big symbols, much bigger than they actually appear on the map. Really hard to read the labels on the map. I mean, basically all of these additional cartographic elements, things like the compass rose, you know, intricate design, taking up a lot of room. Actually, it looks like it's overlapping with the southern border of Texas in some places, kind of blocking it out. Kind of gets in the way of people's frame of reference for interpreting this map. I think the example on the right side, even though it is hard to read the text, is a little bit better, right? It doesn't distract so much from the contents of the map. So assuming this is printed at a page size where the text is actually legible, the design strategies on the right are much more effective. So just a summary of what we just talked about, right? Things that are distracting here, ornate north arrows, large legends, etc. So when I say high contrast colors, you know, I like to think back to a few years ago in the NFL where they had this thing called color rush, and all the teams had these like really vibrant jersey patterns with basically two colors with high contrast, and it kind of was strikingly, it was visually striking. So I kind of like that idea. It doesn't necessarily mean you have to always use these bright neon looking colors. Still recovering from watching the Broncos game on Sunday. My goodness. That was terrible. So some tools that I use to choose colors, like I'm not the most naturally creative person, but when I want some ideas, you know, I've got three kind of places I can point you. It seems like, you know, ChatGPT is this like boogeyman now, but honestly, it is so useful for doing so many different things, especially if you get into any sort of use of programming languages to make maps. If you want to generate some template code that you can modify, check your code for errors, it is such a useful thing. So if you haven't checked this out yet, I'd really encourage you to do so. But yesterday I just went on there and I said, hey, I have a qualitative map. We're going to talk more about this next time, what I mean by qualitative. But I mean, you know, think about an attribute value like, let's say the height of trees. Is like, that's a quantitative metric, right? We're measuring from 0 to maybe 50 meters. The differences between those numbers make, you know, real quantitative differences. Compare that to something that's more ordinal, right? Like the ranking of finishers in a race, 1, 2, 3. Or maybe just a classification of different species of trees, like species 1, species 2, species 3. So I specified I'm going to make a qualitative map here, and I said, can you suggest 5 colors that work well together for a map that have sort of an earth tone color scheme, right? And it came up with these colors and gave me the hex code for them as well. This is what you would typically use with web development. If you're making a map for a web page, you can choose these hexadecimal color codes, and that'll ensure that you're getting the same color on all your different devices. A couple of other tools here you can check out. Color Brewer was actually designed by academic cartographers. It's just a web page, and it allows you to simulate color schemes on your map. I will admit that the built-in color schemes in ArcGIS are not always the best choice. Like maybe this gets better in the future. Maybe they build in artificial intelligence tools to kind of figure out what you're doing. But right now, this is a place where the cartographer has a lot of impact on how the map actually looks. So that's why I use these third-party tools. So first thing you have to choose, right, is the number of data classes. So that could be, if you're mapping government facilities, it could be the number of different government facilities you're mapping. Like we're going to map state capitals, we're going to map libraries, we're going to map universities. You might have 3 classes there. There's also ways of splitting up quantitative data into bins, right? Think about a histogram where you're binning data. That can be considered a class as well. So that's what I mean by classes. In general, you don't want to get down here into the 12 class range unless you're really feeling bold. Using just color by itself, right? You want to use something like changing your symbols at that point. But let's choose 6. Then we have to choose like the nature of our data. So are we going to show variations from the mean? In that case, we might want a diverging color set. Like, I don't know, maybe this is the incidence rate of some sort of disease or some sort of health condition like obesity, something like that. We might have a stronger, more alarming color, something like magenta or even red in this case, right? Indicate negative sort of things, and green indicates sort of positive things. So that would be one option. Oftentimes when you're indicating variations from the mean, I like to have a nice neutral color in the middle. Notice almost all of these color schemes have either a light yellow or a white in the middle, and then colors diverge away from that with 2 different hues. And then qualitative color schemes, there's no real progression in your values. You're not just like increasing how dark green something is. This is going to be better for mapping individual features. Like say you wanted to create a map where every state in a region had a different color, right? Those states can be mapped using a qualitative color scheme. Using this tool, you can also toggle on things like colorblind safe. And it actually can't come up with 6 colors for a qualitative color scheme that are fully colorblind safe, which is kind of interesting. The maximum I can get it to do is 4. So always something to keep in mind, right? About 10% of the male population has some form of color blindness, a lot less frequent in women, but it is a common thing. Print friendly, that would have saved the Wall Street Journal. Photocopy safe, etc. And yeah, you can get your hex codes here. We're going to talk a little bit today about what these different color models mean, but which one you choose really depends on your application. If you're making a map that just is going to be displayed on computer screens, but maybe it's a PDF, best choice is probably RGB color model. Hex would be the best if you're doing any sort of web application, putting your map on a website. And then CMYK is typically best for printing because it's a subtractive color model, meaning that it actually obeys the same physical principles as ink mixing together on your sheet of paper. So it's better suited for printing applications. And then beyond just kind of accounting for these factors here, right, it's sort of up to personal preference which color schemes you like. These are somewhat generic color schemes. They might be a little bit, they're optimized, but they might not be the best looking color schemes. If you're looking for kind of cool color palettes that work together, I really like this website here. It's called Coolers, and there's a ton of different options. And so it's essentially just a color palette generator, right? You can sit here, hit spacebar a bunch of times. Maybe if you're working for a company that has a specific branding color, or maybe if it's Montana State, right? We can get the official colors from the company or the organization, integrate that into the color scheme, and maybe you can use that as part of your design process. So just because you are not super creative like myself, doesn't mean you cannot make these sort of color schemes that are very effective and look really good as well. Just a refresher, who can tell me what type of map this is that is shown on the Color Brewer web application? Anyone remember the fancy term for that? Give it a shot. It starts with a CH. It's choropleth. Yeah, so remember when we're filling in these predefined geographies, we call this a choropleth map. And that's just a fancy way of saying we're using color to indicate variations in our attribute values. Right, your symbolization strategy is going to change entirely if you're doing something like graduated symbols, dot density, etc. So this is just one thematic mapping technique. Whoops. So here's a couple examples of how, use of contrast can vary the perception of the map. I don't think either of these maps is bad. It's, again, we're sticking with this theme of the Gulf Coast oil refineries example. This is a graduated symbol map. And on the right, we've sort of modified it to be a little bit more fancy. Maybe it's a bit more effective. Basically, it means that the size of the symbol tells us about the attribute value. So if we have a symbol that's that smallest size there, it's 50,000 barrels per day of oil refining capacity. And 10x that is 500,000. That's the largest symbol here. Anything outside of that range would just appear as either the maximum or minimum. So you want to set your range to encompass your entire data set. Again, I don't think this map on the left side is bad in terms of colors. I can clearly see those symbols just fine. But does anyone have any ideas about what you might change with the symbols on the left? Are there any problems with it that you see? They're very similar. Yeah, they don't show, well, they're kind of qualitative, right? We're not actually getting a sense for what are the actual numbers. That's one thing. But then there's not much of a change between low and high. And especially where they're overlapping in these high density regions, it's pretty hard to figure out which ones are actually low and which ones are actually high just by taking a quick look at it. I mean, if you pulled out a ruler, you'd probably be fine. On the right side, we've added a transparency to the layer. And you can see overlapping symbols. You can see all the symbols in one area, even if they are overlapped by other symbols. And then the change between the classes is much more pronounced in terms of the symbology. So I like to think of it as portrait mode when I'm designing maps, right? If you want to just convey one thing, try to have the subject of the photo really pop, right? Be in the foreground, principle of hierarchy. The reference stuff is important. Like, yeah, here's a photograph of a dude, he's a shepherd. Gives us context, but maybe not the most important thing on the photograph, so have it fade into the background. These are some of the screen grabs from the Apple commercials when they first introduced portrait mode. Anyone see this new titanium thing? It's so funny. It's like every commercial is like titanium. Like, titanium's a pretty common metal. It's not that big of a deal. All right, so here's an example of a map that is not made in portrait mode, right? There's this dude who likes to dress himself up and paint his body to mix in with the background. That's kind of what's happening here, right? The thematic layer is really blending into the base map. Can't really tell what are cities, what are the actual thematic map layers here. It's all grayscale, which might be good for printing applications. If you're making a publication, it might save you some money with your printing costs, but it's not that effective because nothing really pops, right? So we can modify this. We can add some color to the different thematic map layers. We can vary the symbol as well. So different types of features on the map now have different symbol shapes. Diamonds here are the underground natural gas storage facilities. Circles are our compressor stations, etc. So just making some slight tweaks makes this map much more effective. Questions so far? All right, so let's talk a bit more about these color models and how they actually work. You don't really need to know the details of this, except for there are different color models. You can set up your map documents to use different color models. And as I mentioned before, there's certain applications where you would want to use one over the other. One I haven't mentioned yet is called HSV. You got 3 numerical values, the hue, saturation, and value. You can think about it as this graphical representation of color, where the actual hue is a angle around the central axis between 0 and 360. Red would be defined as 0. 180 would be blue, right? Based on the physics of light and its wavelength. The next value would be how far are you along this v-axis, this value axis, which is if you're mixing your color a little bit with white or black, you can think of that as being the value axis. So if you want to make your yellow a darker yellow or a lighter yellow, you can move it along that v-axis using a number. That number ranges from 0 to 1. And the saturation is how far are you from that axis. If this axis is just black to white with no color at all, if we move further from that axis, we're mixing more and more color in, and the direction we move is going to depend on our hue value. So just using 3 simple numbers, we can describe, pretty much every color combination possible in this HSV color model. RGB is just 3 numbers that indicate the relative mixing of red, green, and blue. I've got a toddler at home, and every toddler YouTube video I throw on is like, what happens when you mix these colors together? I feel like it's something you learn when you're a kid, but you forget about unless you have a reason to know it as an adult. Maybe you actually work with paint and you mix things together. But that's how the RGB model works. You're just adding together red, green, and blue. And this model is reserved for when we're actually using transmitted light. Things like computer monitors, TV screens, web browsers, right? These all rely on pixels on your device emitting light, and mixing together RGB creates colors. So when you're making a map for that application, choose a red RGB color model. I mentioned before CMYK. This is designed to be used with ink because ink is subtractive, meaning it actually absorbs light into the environment when it's printed. So mixing together CMYK can generate all the different colors that you might see on a printed map. And it'll make sure that things, when you actually print them, look more similar to what they look like on your screen. Here's an example of HSV. We can choose our hue, choose our saturation, how close you are to that axis, and then the value, how far you are between that white and black on that v-axis. So I just kind of summarized this, but just to put it in writing, right? The difference between RGB is if you mixed RGB together at its maximum number for all 3, you get white, right? If you mix all the different wavelengths of light, you get white light. With mixing ink together or paint together, if you mix these 3 colors together, you'll get black because it absorbs all the different wavelengths of light. So for print maps, you can honestly use all 3, but for commercial printing purposes, CMYK is preferred. On-screen maps, you should avoid CMYK and use either RGB or HSV, or the hexadecimal codes for web design I mentioned before. We already sort of talked about this, right? But just keep track of these terms: unique, sequential, and diverging. They are useful for different data sets, right? Depending on the nature of your data, you will use different color choices. Here's an example of a choropleth map from quite a few years ago. So who can tell me, what's one thing you like about this map? You can easily pick out the individual states. Yeah, that's a good point. They did a good job with choosing a state boundary color that wasn't overwhelming, but was definitely legible. I think it's like a very light blue or white color. What about the projection? Anyone have a guess about what type of projection is being used here? Do you think it is a cylindrical projection? Raise your hand. Do you think it's conic? I'm seeing some tentative nods. Don't be afraid. Yeah, it's conic. I can tell it's conic because the northern boundary of Montana is actually a line of latitude. It's a parallel, right? It just runs east-west, and it's kind of curved here. That tells me we got that kind of cone shape. I actually like that choice, but you know, might be less familiar to some people. It's very simple, right? These are all things that are good. The map actually has sort of a drop shadow effect, kind of makes it pop. Anything else you observed about this map that you like? I was getting to what we dislike. Yeah, so I mean, if I absolutely had to tell which state preferred We Can Be Heroes by Alesso versus some other song like Desert Night by Rufus Du Sol, like I'm not entirely sure I could do that based on this color scheme. So it kind of looks cool with the branding. It matches the color scheme of Pandora, but there's too many classes here. We've chosen colors that are too similar to each other in favor of staying true to that brand language. But in the process, we've sort of sacrificed the actual legibility of the map. Like I'm not really sure. There's no real rhyme or reason to the order of the colors here either, right? They don't go from like darker shades of blue to lighter shades as well. Yes.
What do you mean by brand?
Brand language, kind of a fancy way of saying like, I don't know, brands sometimes define color schemes that they want to stick to. So that if you see a map, it kind of matches up with like what the rest of their website looks like or the design of their application. That's what I mean when I'm referring to brand language. Yeah. Could also be fonts, right? You might have an official font like Montana State. If you do any official Montana State stuff, we have an official font and official colors, etc. That's all brand language. So we talked a little bit about this, but we have to consider color blindness. There was going back to this example of those color rush uniforms. I remember there was one between the Bills and the Jets where like anyone who had red-green color blindness could not tell which team was which on the broadcast. So that's an example of something that if you're not colorblind, you might not notice, but could be a problem when you produce your map. And then this term visual acuity means that when there's less light, it's much harder to distinguish individual colors. So something that might look great in the middle of the day, printed out or like on a bright screen might look completely different on a different screen. You've probably seen the issue of like trying to read your phone screen in the broad daylight. It's quite difficult. So a few different things you can vary, right? You can vary not only color, but also the types of symbols. So if you have a lot of categories on your map, you might choose to not only vary the color and the shape, but you can mix it together, right? I showed you an example previously of that map from the Gulf Coast region where you're varying both the shape and the color to clearly communicate differences between the different classes of data on your map. That's for line and point symbols. And of course, polygon symbols, you can sort of achieve a similar thing. You can just vary the hue or the saturation of the color to show different soil types. I mentioned before, but my monitor is like really funky up here because that looks kind of greenish to me on the projector at the bottom. But on the monitor itself, it looks like two exactly the same shades of yellow. So another example of how different equipment makes a big difference. There are pattern fills. I'd suggest avoiding pattern fills unless you absolutely have to use pattern fills. There's some, like geology maps, soil maps, it might be more common, but like maps for general audiences, probably a little bit less preferred. We also talked about choropleth maps. So we can also vary, with quantitative data, we can achieve mapping that data with a choropleth visualization as shown on the right side here. To do that effectively, you typically have to break up your data set into bins. And again, we call these classes. So this map has 5 classes, and we've set the class breaks hopefully according to making a conscious decision about where do we want to actually put these class breaks to make the map as effective as possible. So we will have a whole lecture dedicated to classification schemes. They're fascinating, lots of different strategies. And it's one of the basic choices you can make in map design. With point and line layers, right, we can vary the size. We can make like highways a thicker line weight, minor roads a smaller line, etc. We can make them dashed. We can change the color. We have a lot of different options. So I like this map on the right side over here. It's a choropleth map. Who can tell me, is this a diverging color scheme or a sequential color scheme? Yes. It's diverging, exactly, because we got 2 different colors. The further you are away from sort of the average voter turnout, which is in that white shade, the more saturated those colors get. And so it's really meant to highlight variations from the mean. As I mentioned, we will talk a lot more about classification in this class, but I just want to draw your attention to how they broke up the data on this legend. So what they did is they said the average turnout is 50%. Our classes are going to be 10% wide. So like 55 to 65. Sorry, the average turnout appears to have been 57.5. No, sorry, 60 in this case. 60 is the center of that color bar. The bins have a class break at every 10%. And so we can see the highest class starts at 75%. We would call this an equal interval classification, meaning we're going to put class breaks at an equal interval from each other. Another way of doing this could have been defining standard deviations, right? We would expect a data set like this might have a classic bell curve kind of shape to it, where the majority of counties had a 65% voter turnout. Some counties had higher, some counties had lower, but it's sort of a normal distribution. In that case, you might choose different strategies for breaking up the data. You might say, put a class break at -1 standard deviation, put a class break at +1 standard deviation, etc. And that's how you could actually break up your data to most effectively display it. Again, we will talk a bit more about that. So if we're thinking about the completeness of a map, not all of these things are necessary depending on your audience, but I would say this map is quite complete cartographically. We've got a title. It is small here just because of the way that I've actually pasted it on the map. It's called The Share of Adult Citizens Who Voted in 2016. We have a legend right up at the top. That's kind of an interesting design choice. It's like, hey, read the legend first before you actually try to interpret the map. I kind of like that because it's like, why would you just have the reader jump right in without understanding the way we broke up the data? We don't necessarily need a legend for this map because the readership is probably familiar with US geography. Distances aren't a big part of this map story, right? So the cartographer has chosen to drop that legend, that scale bar. For the same reasons, we dropped the north arrow. Graticule probably would be distracting in this case. We don't necessarily need lines of latitude or longitude. It's not a general purpose map. We do have a neat line here. It's not a distracting feature of the map, but it shows us where there is a break in the geography, right? Alaska is not in its true location, and the same with Hawaii, so we have some neat lines. Credits are shown. Credits are not shown because it's probably mentioned in the caption. Something to think about, whether this map is fully complete without credits on the actual map itself. And then we do have a few annotations. For instance, here there's a label that says Minnesota has the highest statewide turnout. Just kind of pointing out interesting features of the map. You know, here's another example at a much larger map scale. This is a map showing one level in a building. Right, we got some neat lines separating features on the map. I think the map feels pretty balanced. You know, it's a little bit subjective, but you want to think about how things are distributed across the map area. We don't want to have everything on the left side and a bunch of blank space on the right. Kind of got this awkward blank space down here. Like I might have taken a legend and kind of filled in that area if I possibly could to improve the balance. In this case, the brand language here is very clear. This is for a university for which they have a similar color scheme, you know, yellow and blue. I like how they've highlighted on a 3D model over here, the floor you're looking at with that yellow color. That's pretty cool. Same thing with the building on campus. You've got a sort of oblique view. This is the building we're mapping. And this is the actual floor we're looking at right now. So I'd say overall, very effective map design. I like the layout generally, and I like the use of color. Here's another example. This map does a good job at filling in some negative space. So when I say negative space, it's like kind of blank space, might be empty based on the shape of your maps. So what this map does is it shows transportation clusters between airports, essentially, and where airports are connected to each other by the most flights per day. So I'd say this is kind of a mix of a graduated symbol map showing the number of flights at each airport with a graduated symbol. Size equals number of routes over here. Kind of an interesting choice to make the legend text, right? We could have maybe used a graphic to show this, but it might have been more busy. Color is keyed to the longitude, so it's really just given us like a rainbow effect. Really purely a design choice, because just everything that's to the west is going to be red, everything to the east is going to be blue. It's just a rainbow. You know, you could have mapped some other metric with color as well, but it wouldn't have had that rainbow effect. Filling in the negative space, we've got these attractive titles up here. We got a little graphic, kind of adds cool design. We've got a sort of zoomed out view of the map showing the full geography. So kind of keying features on the map to the countries for reference. Got some credits down here in the bottom left. Got some annotation where we need it, right? Hey, this is North America, this is Europe. Because we don't have great country boundaries on the map, those annotations are necessary. So I want to highlight in the last part of this lecture how design choices can be misleading, especially if the design choices are not clear to the readership. So every single year we see these, well, every 4 years at least, probably every 2 years, we see a lot of these maps, red and blue, keyed to the political parties. Very easy to read. Most people understand what these maps are telling us. Don't really know what's going on with the massive drop shadow back here. It's kind of an interesting choice that I don't love. Well, let's watch this video again from Vox about election map variations and how they can be a little bit misleading. Shout out to Montana. So I think that's just a concise and very common example of how design can really affect, perceptions of these maps, and can tell a different story if you adjust them. So this is a fancy algorithmic cartogram. Looks pretty weird. Looks like some kind of, I don't know, zombie brain or something. So you could understand why maybe most people don't want to print these maps or don't want to use them. They're kind of in the nerdier realm of cartography, like, hey, look what I can do. Let's collapse these areas that have low population. We're going to collapse them based on a function of population density and expand other areas to kind of population normalize the map. We're going to try to keep this as close to the shape of the US as possible. But it emphasizes, like, hey, just because an area appears very small on a equal area map, it doesn't really tell the whole story of where do people actually live. Those red areas in particular, because rural voters tend to vote Republican in general, they collapse and the cities kind of pop and become much larger. So we talked about some examples of cartograms. This is another thematic mapping technique. Cartograms are more true to the data than they are to geography. So they look fundamentally different. So I challenge you in your lab, especially, to avoid making maps like this. So just want to point out a few things. I was going to have a discussion, but I'm running out of time. Just point out a few things. Like, we got an awkward tail of Alaska hanging out here. Really no reason for that. Lots of kind of awkwardly placed components here. Legends. You can get rid of all the decimal places in your ranges. Probably don't need this north arrow. We don't need it to be like a navigational map from the 1500s either. You might want to simplify that. Awkward breaks on your scale bar. You can drag the scale bar size to get a nice round number. No one is looking at the scale bar to try to figure out the distance that is represented by 1,080 miles. Make that 1,000 miles. In this case, the rivers, like, why the heck are we showing rivers on this? This is a map of household size. There's probably no reason to show rivers. Bunch of awkward space up here. We could have filled more effectively. You might make this a landscape map instead of a portrait map because the United States is elongate east-west, etc. So always think about how your map is perceived. Try to take a step back and think about the design principles.